Coffee, that magical elixir that jumpstarts our mornings and fuels our afternoons. We feel more awake and alert after that first sip. But have you ever stopped to wonder why? What is it about this simple beverage that has such a profound effect on our state of mind and energy levels? Is it just the warmth and comfort it provides, or is there something more scientific at play? The answer, my friends, lies in the fascinating world of neuroscience. Our brains are complex organs, and coffee interacts with them in intriguing ways. Coffee's energizing effects are not merely a placebo, they are the result of a complex interplay between a chemical compound called caffeine and our brain's intricate circuitry. This interaction is what makes coffee such a powerful stimulant. When we consume coffee, the caffeine is rapidly absorbed into our bloodstream. It doesn't take long for it to start affecting our brain, and that's where the magic happens. It travels throughout the body, eventually reaching the brain where it begins to work its magic. Caffeine blocks the inhibitory neurotransmitter adenosine, leading to increased neuronal firing and the release of other neurotransmitters like dopamine and norepinephrine. It travels throughout the body, eventually reaching the brain, where it begins to work its magic. This results in enhanced alertness, improved mood, and a general sense of well-being. But this is just the beginning of the story. To truly understand the captivating relationship between our brains and coffee, we need to delve deeper into the molecular level. The way caffeine interacts with our brain's receptors is a marvel of biological engineering. Between our brains and coffee, we need to delve deeper into the molecular level. This journey into the microscopic world reveals how caffeine can influence our cognitive functions, memory, and even our learning capabilities. Join me as we explore the captivating world of caffeine and its effects on the human brain. Together, we'll uncover the secrets behind that perfect cup of coffee and why it holds such a special place in our daily lives. To understand how caffeine affects the brain, we need to talk about adenosine. Adenosine is a neurotransmitter that plays a crucial role in regulating sleep. Throughout the day, as we go about our daily activities, adenosine gradually accumulates in our brains. Think of adenosine as the body's natural sleepiness signal. As adenosine levels rise, we feel increasingly tired and sluggish, eventually succumbing to the sweet embrace of slumber. This process is essential for our bodies to repair and rejuvenate. This is where caffeine enters the picture. Caffeine's molecular structure is remarkably similar to adenosine. So similar in fact that it can bind to adenosine receptors in the brain. However, caffeine doesn't activate these receptors like adenosine does. Instead, it acts as an imposter, blocking adenosine from attaching and doing its job. Imagine adenosine receptors as parking spots reserved for adenosine molecules. When caffeine comes along, it occupies those parking spots, preventing adenosine from binding. As a result, adenosine can no longer exert its sleep-inducing effects. With adenosine out of the way, our neurons are free to fire at an increased rate. This leads to a surge in brain activity, making us feel more awake, alert, and focused. But caffeine's effects extend beyond simply blocking adenosine. It also influences the activity of other neurotransmitters in the brain, including dopamine, norepinephrine, and serotonin, all of which play a role in regulating our mood, energy levels, and cognitive function. Caffeine's interaction with neurotransmitters is what gives coffee its characteristic buzz. Dopamine, often referred to as the feel-good neurotransmitter, is associated with pleasure, motivation, and reward. Caffeine boosts dopamine levels, which contributes to the feelings of alertness and well-being we experience after that morning cup. Norepinephrine, another key neurotransmitter, plays a vital role in the body's fight-or-flight response. It increases alertness, focus, and attention. Caffeine amplifies norepinephrine's effects, further enhancing our cognitive performance. However, like all good things, the effects of caffeine are temporary. As caffeine levels in the brain decline, adenosine gradually reclaims its receptors, and the familiar feelings of tiredness return. This is our cue to reach for another cup, or better yet, to give our bodies the rest they need. But what happens when we make coffee a regular part of our routine? Our brains are incredibly adaptable organs. They constantly change and adapt to new stimuli and environments, which is a process known as neuroplasticity. This adaptability is a double-edged sword, especially when it comes to substances like caffeine. With regular caffeine consumption, our brains begin to produce more adenosine receptors. Adenosine is a neurotransmitter that promotes sleep and relaxation. Caffeine blocks these receptors, making us feel more awake and alert. However, as we consume caffeine regularly, our brain compensates by creating more adenosine receptors. This means we need more caffeine to block the same number of receptors and achieve the desired effects. Essentially, our brain's response to caffeine becomes less pronounced over time, leading us to consume more to get the same boost in alertness and energy. This is why regular coffee drinkers can often tolerate higher doses of caffeine without experiencing the same jittery effects as someone who rarely consumes it. Their bodies have adapted to the regular influx of caffeine, making them less sensitive to its stimulating effects. But this tolerance comes at a price. The more caffeine we consume, the more dependent our bodies become on it to function normally. This dependency can lead to a cycle of increased consumption and tolerance. When we abruptly stop or significantly reduce our caffeine intake, our bodies can go into withdrawal. This is because our brains, now accustomed to high levels of caffeine, suddenly find themselves without it, leading to a range of unpleasant symptoms. Since our brains have become accustomed to functioning with higher levels of caffeine, the sudden absence of this stimulant can disrupt our neurochemical balance. This disruption can cause a variety of withdrawal symptoms that can be quite uncomfortable. This withdrawal can manifest as headaches, fatigue, irritability, and difficulty concentrating. These symptoms occur because the brain is trying to readjust to the absence of caffeine, which it has come to rely on for normal functioning. These unpleasant symptoms are usually temporary, lasting a few days to a week, as our brains readjust to functioning without their regular caffeine fix. During this period, it's helpful to stay hydrated and consider alternative beverages like herbal tea to ease the transition. Despite the potential downsides of caffeine dependence, moderate coffee consumption has been linked to a plethora of health benefits. Studies have shown that coffee drinkers may have a lower risk of developing type 2 diabetes, Parkinson's disease, Alzheimer's disease, and certain types of cancer. Coffee is also a rich source of antioxidants, which are beneficial compounds that protect our cells from damage caused by free radicals. These antioxidants may contribute to coffee's protective effects against various diseases. However, like most things in life, moderation is key. Excessive coffee consumption can lead to anxiety, insomnia, heart palpitations, and digestive issues. It's essential to listen to your body and find the right balance that works for you. Caffeine's effects are not instantaneous and they don't disappear immediately either. After consumption, caffeine is gradually metabolized by the liver and eliminated from the body. The time it takes for half of the caffeine to be eliminated is known as its half-life. Caffeine's half-life varies from person to person and can range from 3 to 7 hours. Several factors can influence caffeine's half-life, including age, genetics, liver function, medication use, and whether you're pregnant. Understanding caffeine's half-life can help us make informed decisions about our coffee consumption, especially when it comes to timing. For example, consuming coffee close to bedtime can interfere with sleep, as caffeine may still be active in our system. Now that we've explored the science behind coffee's effects, let's delve into some fun facts about this beloved beverage. Coffee beans are actually seeds. They come from the coffee cherry, a fruit that grows on coffee trees. Brazil is the world's largest coffee producer, followed by Vietnam and Colombia. The most expensive coffee in the world, Kopi Luwak, is made from coffee beans that have been eaten and partially digested by civet cats. The word coffee is believed to originate from the Ethiopian region of Kaffa, where coffee plants were first discovered. Beethoven was a renowned coffee lover and allegedly insisted on using exactly 60 beans to brew his cup. So the next time you savor a cup of coffee, take a moment to appreciate the fascinating interplay between this beloved beverage and your brain.